This is Food Chem Unit 5, and we're going to focus on yeast and bacteria and the different types of fermentation effects that you see in your food. So let's start with the yeast. The Babylonians, as early as 6000 BC, used yeast to make beer. In Egyptian tombs, dated to about 2400 BC, there's evidence of commercial production of leavened bread, wine, and beer. Breads, alcoholic beverages, and vinegar all require yeast. Saccharomyces cerevisiae is the most common yeast. It grows best in warm, moist environments with sugar and starch. Saccharomyces means sugar fungus, and that's what's in this picture right here. It relies on sugar for energy. It feeds on sugar, honey, molasses, or corn syrup. But if the levels are too high, the yeast will not grow. I will post this video if you're curious. This is Wonder Bread in the factory, how it's made. But in any case, bread. Yeast fermentation changes heavy, dense dough into a light, porous bread. The dough needs to be proofed or allowed to sit in a warm environment. And at this time, yeast releases enzymes so it can feed, grow, and multiply. Enzymes will break down sugars in the dough and release alcohol and carbon dioxide as byproducts. Carbon dioxide is trapped in the dough, and the pressure of that trapped gas increases the volume of the gas and allows the gluten to stretch. That's why the dough rises. Baking evaporates the alcohol and kills the yeast. Any yeast left in the dough adds to its flavor and nutritional value. The carbon dioxide will expand as it's heated, and a crust will be formed. This all requires proper temperature, proof time, etc. Undesirable texture and taste will result if any part of this equation is off from making bread. Wine. Wine is the fermented juice of plants. Honey, grapes, dandelions, and other fruits can be used to make wine, but grapes are the most common. So the grapes themselves actually have a yeast on them, but if the grapes get treated before they enter the winemaking process, then you have to add the yeast to it. So grapes can be treated with sulfites to stop the growth of unwanted microbes. Now the yeast that's used in this process, which is naturally found on grapes, but if it's treated, this will have to be added in, is usually Saccharomyces cerevisiae. The yeast feeds on sugars in the fruit juice, releasing alcohol and carbon dioxide, just like what we saw for bread. Fermenting juices are held in oak barrels on large stainless steel tanks until the carbon dioxide bubbling stops. The wine is moved to vats or barrels for aging because flavors develop over time. Now, sweeter wines have the fermentation process stopped before all the sugar breaks down. So this is about an 8 to 9% alcoholic wine. Drier wines have fermentation going to completion. So this is about 12 to 14% alcoholic wine. Sparkling wines or champagne use the carbon dioxide given off as a byproduct, hence the bubbling. Okay, fun fact, the wine color is actually from the grape skin. So if you've ever eaten red grapes versus green grapes, the inside is the same. Only the outer skin is different. So pink wines have the skin of grapes removed 1 to 2 days after fermentation begins. Red wine removes the skin 5 to 10 days after fermentation. White grapes can produce white wine, but so can red grapes. You just have to take off the skin. All right, so let's look at bacterial fermentation. Okay, yogurt. Bacteria will ferment milk, and a sour taste will be left from the acids that are released as a byproduct of fermentation. And if you ever look on one of your yogurt cartons, you will see like L. bacillus on there. So you do have a bacteria in your yogurt. Lactic acid fermentation. Okay, bacteria can produce lactic acid as a byproduct of fermentation, and that lactic acid can be used for different foods. Sauerkraut is what we call an acid cabbage. So we did talk about this earlier, but what does this have to do with lactic acid fermentation? Cabbage can be submerged in brine, which is a 2 to 3% salt solution. Now, the salt discourages unwanted microbe growth, but pulls water with dissolved sugar and nutrients to the surface of the cabbage for lactic acid bacterial fermentation, which adds to the taste. Pickles. Cucumbers can be turned into pickles along with watermelon rinds, beets, cauliflower, okra, and onions. They're washed in a chlorine solution to remove yeasts and molds. They're packed in a brine, there's that word again, that's a salt solution, and lactobacillus, that's the bacteria, is added. Bacteria feed on sugars in the cucumbers and release lactic acid into the brine. This lowers the pH and gives a crisp texture and sour taste, hence the pickle. Meats. Meats can be fermented with lactic acid bacteria to make semi-dry and dry sausages. The acid level is increased during fermentation and meat is tenderized. Fermentation plus smoking and drying the meat prevents spoilage. Fermented sausages have meat mixed with sugar, salt, lactic acid bacteria, and spices. Sugar is food for the lactic acid bacteria. Salt prevents bacteria causing spoilage to die, and spices are added for flavor, in case you were wondering. Cultured dairy products like sour cream, yogurt, and buttermilk will use lactic acid bacteria. Streptococci bacteria are the fastest lactic acid producers. Okay, so milk has microbes, right? Because it's coming out of the animal. So this needs to be pasteurized or heated to destroy any unwanted bacteria. So once you have that pasteurized milk, you can add a starter bacteria, which will feed on the lactose in the milk, release lactic acid, carbon dioxide, and flavor compounds. The products are then cooled, and we can use this for yogurt, for example, right? Just plain yogurt. Now, the acid denatures the proteins and causes coagulation or clumping. The degree of coagulation or clumping depends on the combination of bacteria, temperature, pH, length of fermentation, and added enzymes. Now, why am I telling you this? Because this results in different types of products, like sour cream or yogurt. That's why one tastes more sour than the other. Cheeses. These will again start with the pasteurized milk. Rennin, which is a proteolytic enzyme, proteo means protein, and culture of lactic acid bacteria are added to make curds, or clumps of coagulated protein, which is known as casein. The curds can be heated to separate the whey. The whey is a liquid high in whey proteins that can be used in other baked goods, mixes, and margarine. Now the curds can be salted for flavor and to reduce spoilage. That's why we're adding salt. The remainder of the process, what you do to the rest of those curds, depends on the type of cheese that you want. Cottage cheese would be curds mixed with cream that has cultured milk added. Cheddar, Edam, Swiss, brick, and blue cheeses are aged and put in presses to squeeze out juices. There's a ripening period that allows bacteria to remain and produce flavor. The cheeses are covered in wax and put in curing rooms with controlled temperature and humidity. Swiss cheese has propionic acid bacteria that's added. This creates the carbon dioxide that makes the eyes or the holes in the cheese. Limburger and blue cheese have molds added. This lowers the acidity, so proteolytic bacteria can develop flavor, which in these two cases is really strong, texture, and aroma, which is also strong. The sharpness of cheese. This is based on the strength of flavor and aroma and depends on the length of time it's cured. So mild cheddar is cured for 4 months, sharp cheddar is cured for a year, and extra sharp cheddar is cured for 2 years. If you're curious, you can watch how one type of cheese is made. This is pretty cool. It's mozzarella, so it's kind of neat. So I'll post that in Schoology. All right, so now let's talk about mold fermentation. So where would you ever see something like this? Well, it creates byproducts such as antibiotics, flavor compounds, and enzymes. So one example would be soy sauce, which is a fermented mix of soybeans and wheat. And the fermenting agent is a mold from the Aspergillus family. Acetic acid fermentation. So let's look at vinegar, for example. Acetic acid bacteria produce different types of. It depends on the food on which it feeds. So acetic acid bacteria in red wine gets you red wine vinegar. Water plus wheat would get you white vinegar. Apple juice and acetic acid bacteria get you apple cider vinegar. Now the FDA requires that vinegar has a 4 milliliter of acetic acid per 100 milliliter of water or 4% solution to be classified as vinegar. Okay, but now this acetic acid fermentation is also needed for turning cacao beans into chocolate. It's part of the process, and also for making candied citron. This is fermented citron lemons that you might see in something like fruitcake. The nutritional value of fermentation. Fermented foods have different nutritional values compared to unfermented foods. So cheeses, for example, are higher in fat than milk. If the whey is drained off, the fat becomes concentrated, and the casein or protein molecules are more attracted to the fat. Calcium is increased in cheeses. Iron is increased in sauerkraut. The salt content is also increased in a lot of fermented products. That's that brine solution that cucumbers, for example, were soaked in before they become pickles. And I can't leave you without mentioning this guy, Louis Pasteur. So you've heard the term pasteurization quite a few times in these lectures on microbes. So it's named for Louis Pasteur. So he studied microbes a lot. What he realized at this time is that microbes were a source of infectious disease, which not a lot of people realized at the time. He worked on vaccines. He helped develop the rabies vaccine. He believed alcoholic fermentation was caused by yeast. He believed lactic acid fermentation was caused by organisms, which we now know as lactic acid bacteria. So he was right. He knew microbes cause bitterness in wine. Pasteurization, or that heat process, so heating the wine, protected the wine from these microbes, and this was later applied to milk and beer to preserve them.